All right, so we're going to find the equation of the tangent line here to the curve at the given point here. So here's the point in question. Maybe I'll just make that a bit bigger for you so you can see in the back. And
Can I get the lights?
yeah, get the lights, sure. And what we need to do, obviously, when we're finding the equation of a line, we need the slope and a point. So the slope comes from the derivative of the equation. So we need to find y prime. Okay, that's fine. What we could do, though, is we could actually simplify y a little bit first. So I'm going to rearrange y a bit, which you might want to do too. This is actually 1 over x to the 5th to the power of 1/2. That's what this root sign says. And so that would be 1 over x to the 5 over 2. And then if we don't want to do quotient rule, we don't actually have to. We could just write this as x to the negative 5 over 2. You see, I'm bringing it up to the numerator. So a couple little simplification steps might make the calculus a bit easier. If you simplify algebraically first, the calculus might get a little bit more straightforward. So I would suggest that we might want to just take the derivative of this function. And we just use the power rule, basically. So y prime now equals negative 5 over 2 times x to the, now we got to subtract 1, which is like 2 over 2. So that's going to be negative what? 7 over 2. Good. Okay. Now, that negative 7 over 2 is an exponent, might be a little freaky too, but what's nice about this is that we're just plugging in x equals 2, right, into our derivative expression so that we can find the actual slope here. So this is the expression for the slope at any point x that's on this curve, and the actual slope of the tangent line is going to come when x equals 2. So y prime, really of 2, I guess you could say, is negative 5 over 2 times 2 to the negative 7 over 2. And if this really freaks you out, let's just simplify this a bit by saying this is going to be negative 5 over 2. This 2 to the negative 7 over 2 is really over, so 5 over 2 over, you can put this in the denominator there. And this 2 as a denominator exponent, that's going to be square root. So we're going to have square root of 2 all to the power of 7, right? Square root of 2, power of 7. Okay. All right, so root 2 to the power of 7, how do I simplify that? Well, let's keep moving on here. So this fraction in the numerator, don't really like that. Let's do this. Let's put the 2 on the bottom. And then it's going to be down the bottom with all this right here. Okay. So if you think about it, root 2 times itself 7 times, right? Sorry, I'm getting there. 1, 2, 3, 4, 5, 6, 7, right? That's what this is. So guess what? We have lots of groups of 2 here. So we're going to be able to simplify this pretty easily. Root 2 times root 2 is just 2. That's just 2 then. And that's just 2 times root 2. So I actually have 2 times 2 times 2, which is, what, 8 root 2? So this is actually times 8 root 2. So the value of the slope should be negative 5 over 16 root 2. And it's okay to have that root 2 in the denominator. I suppose in calculus, that's okay. So that is the slope so far. So all we need now is just the point, and we'll do the point slope form, which looks like this. Y minus y1 equals m times x minus x1. And so we've got the slope, great, and I've got the point, the x value and the y value that's given in the question right here. So to finish this off, we'll do y minus, the y value there is 1 over 4 root 2 equals negative 5 over 16 root 2 times x minus 2, right there. All right, so, I mean, you can leave it like this. They might not require that as a final form. It's just a point slope form, but they might want it in y equals mx plus b or in general form.
Wait, what question is that?
This is 9C.
From
2.9, 9C.
2.9?
Yeah. 2.9.
Oh.
Yeah.
Wow.
You all right there?
I wish I was that far. I have a lot of.
Okay, so this is number 6. The notation might be a bit funny here. This, obviously, dy dx is Leibniz notation for derivative. This little bit right here with the square brackets and the x equals 1 down here means that we find the derivative and we evaluate that derivative at x equals 1. That's what that notation means. So it's kind of like if the y function was in function notation, then this derivative would be f prime of x, and then this whole thing would be the same as f prime of 1. Okay? So that's really what this is. Okay? So this right here is the same notation as this. The derivative of the function evaluated at x equals 1. Those are the same. So on that note, let's take a look at this. Now, what we have, I'm going to show you this in Leibniz notation because we have y with respect to, u, goes over here. And then we have what is u here. So dy dx, using the chain rule, can be written as the derivative of u with respect to, no, we're going to go, derivative of y with respect to u, and then times derivative of u with respect to x.
Wait, what?
So this is the chain rule expression using Leibniz notation.
Oh, yeah.
Because really, this du here, it ends up with dy dx, right? But we do it in 2 stages. So the derivative of this y function right here, with respect to u, here is the expression with respect to u. So the derivative of y with respect to u is this, 2u minus 3u squared plus 8u cubed. Everybody see that? That's the derivative of y with respect to u. Now we multiply this by the derivative of the u function with respect to x. So multiply that by, oh, this is a quotient. Yeah, question?
Oh, no, that's stretching.
This is a quotient. So we're going to do derivative of the top, remember with respect to x, the derivative of the top is 1, minus the times the bottom, derivative of the top times the bottom, minus the top times the derivative of the bottom, which is just, looks like 2. All over the bottom squared, 2x minus 1 all squared. Okay? Now, do I need to simplify this? Not really. I don't really need to simplify it, but what I need to do is I need to find this, right? Evaluated at x equals 1. So you have 2 options here. You can rewrite every u as this, x over 2x minus 1. Or you can figure out what u is evaluated at 1, at x equals 1.
Oh, and then
Which that might be pretty easy. So that's 1 over 1 is 1. Does that look good? So now u with x equals 1 inputted in it, wherever you see a u is now just 1. Okay? So u evaluated at x equals 1 is just 1. You okay with that?
Yeah,
So this
the
is-
other way is fine, right? Just
The other way is okay too. If you want to plug this in wherever you see u, and then just plug x equals 1 in, and you're good to go. This is a bit of a shortcut, I think. But that's okay. But whatever you feel more comfortable with.
that's so cool.
Okay, so there's that little bit. And then this little bit over here, this is going to be 1 times 2 minus 1. So that's 1 times 1 is 1. Minus 2 times 1 is minus 2. All over, and this is 2 minus 1 is 1 squared over 1.
Wow.
So doing some simplification, 2 minus 3 plus 8. All that times negative 1. So negative 1, that's positive 7, negative 7.
That's so satisfying.
So that is the correct answer there. That is the derivative of this function evaluated at x equals 1. Okay, questions? What are we all whispering about here?
We're gonna go to for some reason, this scary math made us think of horror.
Yeah.
And then like,
I don't know.
associated it with
I'm just
October.
thinking October, scary math, scary things.
It was on the blue for
This is not,
There should
this
be a
is
calculus
not a
on
I'm
this
just
math
saying, if I'm walking
discussion.
through a shock house and someone just shoves this in my face, I'm gonna faint.
Yeah.
You're equating horror with this math. That's a gross misrepresentation.
Well- No, I thought it was the funny
All right, so 4E on the 2.9 says differentiate this. So this is a product of two functions, this function 1, this function 2.
Oh, okay, never mind.
So you want to do product rule.
Yeah, okay.
All right, let's go. I'll walk it through with you. So the derivative of the first, now, hey, do you want to rewrite this as x to the 1/2 maybe, right? 5 minus x to the 1/2, you might want to do that. That might make it a bit easier. So the derivative of the first is 1/2 x to the negative 1/2 times the second plus the first x to the 1/2 times the derivative of the second. So what's that going to be? That's going to be negative 1/2 x to the negative 1/2. Okay, so it looks like that's the first level of differentiation there. If you're asked to simplify that, we'll go forward and simplify that. Yeah, okay. So how do we simplify this? Well, oh boy, we've got lots going on here, don't we? You can do a couple things. You could take this and you could distribute it first if you want. Why would you do that? Because these x exponents, see, they're gonna like cancel each other out a little bit here when you add negative 1/2 plus 1/2. You don't have to do that, but you could. Might be not a bad idea. So let's do it that way if you want to just distribute that. So this is going to be 5 over 2 x to the negative 1/2. And this is going to be minus 1/2 x to the 0. What's x to the 0? It's just like a 1, right? Okay, so that's that. And this one is going to be minus. This is just one term. This is just one term, I guess, right? So we've got minus, we've got 1/2, and what's x to the 1/2 times x to the negative 1/2? That's just 1. Okay. Okay, so we're kind of getting there. We've got 5 over 2 root x minus 1. Now that would be perfectly fine. Leave it just like that. Y prime. So for e, 5 over 2 root x minus 1. Beautiful. That's the answer we should get. If you want to make that one term, you totally can. This is going to be 2 root x over 2 root x. So it's 5 minus 2 root x over 2 root x. But is that simpler? Not really. Okay, so you can either one of these.
2 to the power of 3 is 8, right? 1 over 2.
Okay, so this is from 2.6. This would be a quotient rule, chain rule, I guess.
2x times
You have options here. If you want to make this into a product, you can. Or if you want to keep it a quotient, you can
That's what
too.
I tried to do. I tried to make it a
That's the
product.
Yeah, try to make it okay, do you want me to do that product
Yeah, can we do
way?
product?
Yeah, sure.
Yeah, that's
So then I would just rewrite this as x times 2x plus 3 to the power of negative 1/2. Did you do that?
Yeah.
Got that far?
I
Okay.
did that part.
So now we can do product rule, which would be here's function 1 and here's function 2. So we're going to do the derivative of the first, so f prime of x, derivative of the first, 1 times the second, okay, plus the first times the derivative of the second. So this is going to be now negative 1/2, bring that down,
Yeah.
times 2x plus 3, leave that alone, subtract 1, negative 3 over 2, times the derivative of what's inside, or 2.
Yeah.
Okay? So that should be your first step. If it
That's
says
what I have.
do not simplify, then you're done. That's good. That should be everything. Now, to simplify, so what we want to do then is we'll notice this right away, right? You have 2 up top and 2 on the bottom. I also noticed that this portion of the first term has a negative exponent. So that's going to be 1 over root 2x plus 3. If you can, we can put that back to a root. It's a little cleaner. And then this one's going to be what? Well, it's going to actually be a minus, I guess, because of this. So minus, what's on top? The x is on top. And the 1. Yeah, well, you've got the 2's here. They're gone. So you don't have to worry about the 2's. They cancel out. So then I just have an x on top, and then I have a root 2x plus 3. But this is all cubed now.
Yeah.
So that's all cubed. Okay.
Wait, yeah, can you do like 2.6 number 8?
Yeah, I'm just going to finish this one first. Now, to simplify this, to cram those together, it's not that difficult. But what we want to do is we want to make this root 2x plus 3 all cubed. I guess we want to get a common denominator, right? So if I make this cubed, that means I have to have a root, 2x plus 3 squared on top.
Yeah.
Because I need to multiply by 2 more. Which opens up a couple neat possibilities. First one is when you have a square root squared, it cancels each other out, so you end up with having this on top. The other thing is, I don't know if this is necessary. Is it? Probably should be. If you have this cube down here, that means you have at least 2 of them that are multiplied together. So you do have a 2x plus 3, and then times a root 2x plus 3. So technically, that's, I guess, simplified. And then because 2x minus x just gives you 1x, maybe I'll just do this the fancy way. Yeah. Now, you see what I did? I just combined
Yeah.
the top terms there.
I think it's just what the back of the
So
book wants.
6e.
But I think the back.
Yeah, the back doesn't simplify it like this, so it leaves it as a 3 over 2 exponent, which is fine.
Okay.
Oh, I
Um,
tried doing that
yeah.
question with the quotient rule.
So you could, yeah, this is the way the book has it, which is totally fine. They just kind of leave it in this form right here, yeah. So 2x plus 3 to the power of 3 over 2, which would be fine as well.
Oh wait, I didn't finish that.
4. Okay, so I'm going to do, because I changed the other one to product, I'm going to do this one quotient, okay?
Oh.
Is that okay? Just going to leave it as a half? Or do you want me to do a product because that's
Could
what...
you please do it
Yeah, I can do a
product?
product then, fine. Okay, so then this is just going to be, 20 minus x to the 4th to the power of negative 1
Yeah.
half, correct?
Yeah.
Because this is a positive 1 half down here, and then you bring it up, makes it negative. Okay,
Mhm.
so finding the derivative is going to be negative 1 half as a coefficient. Just bring that down. Leave this alone inside. Do not touch it. Subtract 1, so it's going to be negative 3 over 2, correct? Times, now the derivative of this. This is where you touch this now
Oh,
and
I
get the
forgot
derivative.
of that.
Negative 4x cubed.
Yeah, I forgot.
Did you forget that chain rule part?
Oh,
Okay,
yeah, I forgot.
chain rule part. Good. You don't want to forget the
There we go.
chain.
Yeah,
Don't
no,
forget the
I think I
chain
figured it out
rule.
now.
Okay.
I just forgot that
Yeah.
part.
Okay, so this makes this positive. We've got a 2x cubed, and I've got now a, I guess this 20 minus x to the 4th to the power of 3 over 2 down here. And I just want to get x equals 2 in here, right? So let's do that here now. So that's going to be 2 times 2 cubed up top. This is going to be 20 minus, x to the 4th, what's it, 16? To the power of 3 over 2. So that's going to be 16, 2 times 8, over 4. The square root of 4 is 2, cubed is 8. So we should have a slope of 2. We good with that? Now I went extremely fast there. Apologize, but it's all written down. Just put in 2 and simplified. So I'll pause there. Is that
Yeah,
is
nice.
that okay?
Yeah, I got it now.
Okay.
Yeah.
And then, of course, to complete that, we want to find the equation of the tangent line. We want to use this and the point that's given. So lovely, we have x, y, a given point.
Yep.
So I just go ahead and do y minus, what's the y value of the point given? That's 1 half. The slope here is 2, so that's 2 times x minus, what's the x value? That's 2.
2. Yeah.
So there's your equation in point slope form. Y equals mx plus b form would look like this. So we have 2x minus 4, minus 3 over 2 or 7 over 2, 3.5, 7 over 2.
Yeah.
And then in, I don't know, general form, I guess, that they might have in the back of the book,
It's like
you go 2x minus y minus 7 over 2 equals 0. They don't like any fractions though,
Yeah.
so multiply everything by 2,
4x minus 2y minus 7.
like that. So either of these are, or I guess any one of these probably would be good.
Yeah.
This one's not really worth much for graphing and stuff. It's hard to, that y equals mx plus b is nice for graphing, and this,
That's
I don't know. This is just
What?
maybe
Yeah,
formal.
like
It's just a
what?
formal way of doing it, a general form.
formal.
I'm not sure why the textbook chooses to put
But
none
I
of this.
feel like the most logical. Huh.
So the usefulness of this then is, in this case, if this is A, this is B, this is C, negative C over A is your x-intercept. Negative C over B is your y-intercept.
Huh. Okay.
So that's I guess what's good about that.
Cool.
Yeah,
Weird.
yeah. And then if you have 4x minus 2y equals 7, I think this is standard form, but I could be wrong. Then it's just positive C over A is your x-intercept, and C over B is your y-intercept.
Because you can just do negative
Hmm.
b over
So-
2a, or no, b over 2a.
Negative b over 2a is the x value of the vertex of a parabola if it's
Oh.
quadratic.
Yeah, that's not the intercept.
That's has nothing to do with
No,
this.
you can just plug in the 0 for
Yeah.
the x or the y. But I feel like you can do it for the y.
No.
Yeah, you plug in 0 in for x and then solve for y to get the y-intercept.
Yes.
Plug 0 in for y, solve for x to get the x-intercept. All right,
Huh.
Okay.
All right.
that's the end of this little review.